as well as looking at the possibility to get the alternative energy. This is called renewable energy as an initiative. So in our country, for example Malaysia, the government already focused in these two for the past 10 years. Quite a number of initiatives and policies already being developed on how to go about and how to increase our awareness and the implementation of this initiative for renewable energy and energy efficiency. For my presentation today, I will be focusing on energy efficiency, of course, and my focus will be on building design. Okay, the energy efficiency can be understood as programs that are aimed to reduce the energy used by specific end-use devices and systems, typically without affecting the service provider. This is some of the initiatives implemented in Malaysia, what we call as energy efficiency initiative and renewable energy initiative. As you can see there, the government developed some program and project as well as incentive, what we call tax incentive for energy efficiency. That one is in the budget 2001. There is a program on energy efficiency such as demand side management, developing activities for energy rating and labeling, and the one that I highlighted is actually related to buildings, the design of low energy office building for Ministry of Green Technology, as well as green energy office building, or previously called zero energy office, as well as the latest one is the design of energy commission headquarters in Putrajaya called Diamond Building. And we have also millions of ringgit budget on Malaysia Building Integrated Photovoltaic, BIPV. So this is some example that I think as a designer for the future you should understand, because some of these initiatives actually is available for architects as well. So I think architects and engineers should aware of what the government can offer for you, so that you can get involved in some of these energy efficiency or renewable energy initiative offered by our own government. Apart from energy issues, environment and global warming, which is because of carbon emission, I would like to refer to one article wrote by Professor Peter Davis from UPM. This is related to human comfort, of course. When we talk about building design, we concern about the use of energy, but at the same time, our main focus as a designer of the building should be providing human comfort for the occupant. Of course, we care about using low energy, but make sure that the occupant who will occupy the building should be comfortable to perform their duties. So according to Dr. Peter Davis, Muhammad Peter Davis, research revealed that 2 million modern concrete houses, maybe terrace houses mainly, had drastic internal temperature increment due to direct solar radiation to the building envelope. So, who actually designed the building? Of course, an architect. So I think this research has been done more than 10 years ago, and this is the finding. So when Mr. Muhammad Peter Davis explained his finding, everybody start to look at the architect and why such building provided for the human being. And again, because of extreme hot condition and uncomfortable, nations spend their time outside their home 2 to 3 times more rather than staying at home. So if this means that it will be creating another problem. Okay. But then Malaysia towards 2020, one of our objectives is to have masyarakat penyayang, or what we call in English, a caring society. So before you care to the society, you must care to your family. So how can if you spend a lot of your time outside your house? So architect will contribute especially to the social problem if this continue. Okay. So this phenomena is very unfortunate because home is considered as a basic need in our family life and should be conducive and comfortable to live in. The study also shows 50 to 75% of the population were not happy with their own terrace houses that they purchase. So the impact of the above condition also shows 62% contracted headache, and 1/3 of them often have temper problems. So whatever you decided on your design decision making as a designer or as an architect, the impact will be on social as well. Okay, for that, let us come back to our basic principle in our design. I think all of you already taken basic subject on environmental. In UTM we call Physics Lingkungan 1, Environmental Physics 1 and Environmental Physics 2, and followed by Climatic Architecture Technology. So these 3 subjects is very, very important. And usually in architectural education, this subject must be integrated in the design exercise in the studio. Okay, so this is roughly the images of basically some of these guys in my family, my brothers and my uncles' house. You can see how happy they are if the house is in the comfort zone, comfort condition. I just want to roughly summarize. This is roughly the external condition of our country, Malaysia. Average temperature between 26 to 32, maybe a little bit more. Relative humidity is about 80 to 90%. Air movement actually varies, depend on the weather. And then solar radiation can reach up to 1000 watt per meter square. So these 4 elements is actually the part of the climatic elements or comfort, human comfort elements. And this is what the comfort zone from research done by previous researchers. They found out that the average temperature range for comfort zone in Malaysia is between 25.5 to 28.5. This is research finding by Dr. Abdul Malik Syukur in USM. So make sure that in your competition, you prove that your temperature must be within this range. And relative humidity between 45 to 80.6, and air movement about 0.1 meter per second. And the radiation should be around 100 watt per meter square. The last one, that is not under the human thermal comfort, but it's important for human to carry out activities in the